said quiz tomorrow that you are allowed to use your calculator. We are going to need to go back and forth between a couple different modes, right, guys?
Yes.
Because 10.6 is all about what mode? Good. And 10.7 is all about what mode? Good. So we're going to have to be able to use our calculator for both. I'm going to try and open up my calculator again. I know the screen's frozen. My calculator was very mad at me earlier today. We just went ahead and graded section 10.7. Then we're going to work on the quiz review after that. For anybody just joining us who might be gone in periods 2 or 5 today for an AP, go ahead and pause these answers as you need them because we already went through these. There's 26, 52, 72, 98, 108, and 122. All right, with that, kiddos, let me go ahead and pull up section 10.7. Let me get you guys back to where I am. There we go. Do we have any questions that we need to see, odds or evens? 127. I'm hearing that a lot. AJ, what else? Okay, so let's hit 85. Let's hit 113, and then let's go ahead and hit 127. Chris, you have another one?
Maybe 117.
Okay. Okay, let's hit 85. I don't think so. 85, let's go ahead and hit that one first, then 113, 117, and 127. If you are like, I'm bored, I was awesome and got it all done, no questions whatsoever, didn't I tell you all to get a book, and don't you all have the quiz review written down? Go team. But if you're not bored because you didn't have homework all the way ready, then let's talk about where things got rough. And this, someone double check the directions for me. My guess is that it said to convert from rectangular to polar. How do I know that? There are x's and y's. That's rectangular. What variables, preparing for tomorrow, what variables are polar? R's and thetas. Good. So, guys, did we yesterday talk about a yellow circle, yellow box around 4 important formulas in 10.7? Do you have those 4 formulas highlighted? I hope so. Do you guys understand when I say to memorize something, I really, 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 really mean to memorize it? Like, for instance, on the last test that I'm not giving back until tomorrow after you guys finish your quiz, although they are mostly graded if you want to come at the end of today, not 7th period, but after school because I'm subbing, I could show it to you. But I had people not know the formula for eccentricity on that quiz, or on that test. Isn't that sad? How many times did we go over the yellow boxes, what you needed to study last chapter? I had people not know what an ellipse was versus a hyperbola, which one had pluses, which one had minuses. I had people not know the c-squared formulas. Like, that over and over and over and over. And maybe you don't get things memorized in class, but you have to study. 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 Right? Study for a math test. Study for a math quiz. Care about passing the class. Some of you that for some reason don't seem to be caring right now. I really don't want to fail you this semester, but I will if I have to. Not because I'm choosing to judge you, it's because you haven't put in the effort. So, when I say these 4 formulas aren't important in 10.7, do I mean it? Yes. So what are you supposed to do tonight with those 4 formulas? Memorize, study. Yeah? And if you memorize, study, hopefully you would pick out, hey, x squared plus y squared looks super, 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 super familiar. Equals r squared. Some of you already have it memorized. But have some humility and you study for tomorrow too, because maybe some of you blank out on a test. Maybe some, not social, but test anxiety, something like that going on. So you study too. Even if you got it right this second, doesn't mean you'll have it right this second tomorrow. So study. Now, here's a dilemma. Who on earth is x? There's a formula for that. What's x equal? So if you have it memorized, it's easy. You plug and chug, right? Okay. Now, I do see there's an r in both, right? So I can pull out an r. Now it's a little bit of algebraic struggle. I have r minus 2a cosine theta equals 0. Double check me. An r comes out, so one r comes away from him, one r comes away from him, and I have just one r left, and then the 2a cosine. What do? I'm guessing that the directions are to Michael and Josh. We're doing okay back there, like being productive? Cool. So then, guys, if we're trying to solve this, which I think it says to convert Does it just say to convert? Oh, it just says convert. Well, then technically if it just says to convert, I guess we already did convert. But kiddos, they could have simplified it a little differently. They could have tried to get r by itself. Does anybody have what the back of the book would have said as far as how to solve? Or did it say to solve? It's an odd. No one checked the back of the book? You guys, what's going on? I can open up my solutions, but as you notice, we're kind of wasting some of your work time. Alright, those of you who are turning to the back of your book, thank you so much. If you beat me, I would really appreciate it. I'm just coming in here so that we can see it for later. Okay. So they did go ahead and keep going. I had this up just in case we need it later. But what I meant by keep going is normally when we have an equation equal to 0, don't we set everybody equal to 0? So we have to set that equal to 0 and that equal to 0. So we have r equals 0 or r minus 2a cosine theta equals 0. Guys, how do we get r by itself? And that's exactly what AJ just read. Now, according to the problem, maybe it says that r can't equal 0. Technically, that would be another solution. It says a can't be 0. He has to be higher than. It doesn't say that r needs to be anything higher than. So I would say r equals 0 or 2a cosine theta, technically. But AJ, the back, just said that one, the right one. Okay. Probably because r equals 0, guys, think about that. What are all the points r equals 0 and beta equals anything? It's at the pole. Good. It's at what we would in the olden days call the origin, but now we call the pole. The next question I heard, AJ, I think it was yours, right? Number 113? Yeah. And then Chris, you had number 117. Yes. Two totally different sections, but the same idea of converting, I think. Because for number 113, yeah, and you guys can tell that by the question, right? Because what's in this original one? R and theta. And then, so what am I trying to get to? So I'm trying to ideally get y by itself. There are a couple different ways of doing it. Let me just set you up for it. Ready? And I just want you to see which one's better in your head. I just need to see which one's better in your head. How many of you guys would think, ew, division, let me undo the division first, versus, oh, hey, I think I can kind of get an r formula and kind of get a sine from the right triangle. Okay. I'll kind of show both because I had a couple hands on both. If we multiply first, saying, ew, division, and I've tried to show you that all year, like, ew, division, we got to somehow change things up. If we were to distribute to the other side, do you guys see how I'd have 2 times r and 3r sine theta equals 6? Because you would have to multiply by both and distribute. And yeah, one of you guys already was like, I think Jackie, that was you, right? You're like, r sine theta, that is something. Yeah. And then, I still have r. Okay, hold on. Look at your formulas. I said there were 4 main ones. X squared plus y squared is r squared. Tangent of theta is y over x. X equals r cosine. Y equals r sine. Which one might help me just get r? But see the y equals, if I chose that one, I could get it, but the problem is, wouldn't I have to get a... Yeah, I would get a theta back in. I don't want a theta. But Leo was like the x squared plus y squared is r squared. That one's so close. All I have to do is... Yeah. So I can just throw in a square root and be like, sweet. 2 times, technically plus or minus, the square root of x squared plus y squared minus 3y equals 6. Now guys, there are things that we could do. Like we could go ahead and move the 3y to the other side. We'd have plus or minus 2 square root x squared plus y squared equals 3y plus 6. Then we could square both sides. Like there are ways of simplifying. That'd be 4 times the square root goes away. On this side we could actually FOIL it out and get 9y squared plus 18 and 18 is 36y plus 36. But do you guys see how these y's, they're not really getting alone? Like we could go ahead and distribute, we could go ahead and combine my terms, but we still have like a y there and a y there and... Why would you do Yeah. So this might be one of these where it's a little impractical or a little irrelevant. That was clever. To get y by itself. Ba-dum-bum. So we could keep going, or we could stop a little early, but getting y by itself in this one isn't going to be necessary. And as you guys looked at the back of the book, actually, I could show you real quick. They didn't always get y by itself, did they? No. I don't think so. Sometimes they were like, you know what, only do it when... where are those 100s? Oh my goodness, it's taking forever. Here we go. Sometimes check it. Sometimes they left it nasty. Sometimes they left it nasty. They were saying, you know what, it's just not really practical to get y by itself, so don't stress about it. Kind of like with conic sections, we had x squares and y squares and didn't really stress about y by itself. Same thing here, it's totally okay. So, AJ, that helped with 113? Chris, you were thinking 117?
Yes.
The ironic thing is he's actually so easy, he's hard. So easy is hard. You guys have two options. One is to say, ugh, is there any formula that will help me just with r? Just x squared plus y squared is r squared. What can I do to something if I'm just trying to get r and not r squared? I can do plus or minus the square root of x squared plus y squared equals 6. That's one way. I could square both sides because this one's easy. Oh, look at what we could have done. Couldn't we have taken the r and couldn't we have done a quick little, like we did with tangent yesterday? Couldn't we have squared it and been like, oh, r squared is 36. Oh, hey, r squared is x squared plus y squared. So sometimes you can kind of manipulate things just a little bit. You can put in a tangent to both sides, or you can square both sides to make it easier before the substitution. But question, was I still able to get there just going the straight substitution route?
Yes.
What is this guy? A circle with a radius of 6. Doesn't this make sense? They're just saying r is 6. I won't tell you anything about theta. You're like, sweet, go out 6, go up 6, go back 6, go down 6. It's the whole thing. Sorry about the nasty circle. The last one. I heard a lot of you guys being like, 127, please? Okay, 127. He was the Ferris wheel dude. Now, I did give you an odd, not an even, for your Ferris wheel dude. Plus there wasn't, oh, there was an even Ferris wheel. Anyway, I gave you the odd. This was just trying to somewhat apply for you when polar graphing would be helpful. When polar graphing would be helpful. If you were trying to graph or model the movement or the positions of a car on the outside of something that moves in a circular pattern like a Ferris wheel. You could also talk about like a tack in like a wheel on a car. You could talk about like a fly that got squished on a bicycle tire or any, those are silly examples. But anything that moves in a circular pattern. They give us a lot of things about this Ferris wheel. They give us that we have this guy off the ground a little bit, right? Somehow he's being attached, I don't know. So this Ferris wheel looks like a hamster wheel. Anyway. We know passengers enter a car at negative pi over 2. Negative pi over 2. Guys, isn't negative pi over 2 straight down? Yeah. Why does it make sense that passengers would get in a car right here?
It's the clock.
There's some sort of like, right up there to get into the Ferris wheel. Okay. So then 30, 30 is like how many radii there are, right? Okay, so I have 30, that's how many radii out, like how many feet or how many meters or how many, whatever the measurement is as far as how big the Ferris wheel is. 30 and negative pi over 2. Okay, passengers get in right here at the bottom of the Ferris wheel. Then it takes 45 seconds for them to make it all the way around, right? One clockwise revolution. Oh, clockwise, I guess it goes the other direction. Lo siento. Just kidding. Yeah, isn't that weird? That's what I thought. Because you usually like to go up, right?
Yes. You don't go up backwards.
Oh, well. Oh, maybe the cars are facing this way. All right, coming back.
Okay.
Life is better.
Science deduction.
Oh, feet. Go team. Okay. Write a polar equation that models the possible positions of a passenger car. Don't we just need this guy to go around in a circle? Right? How do I model a circle with a polar equation? Didn't we just talk about one?
Yes, we did.
So we could do something snazzy and be kind of, I guess, smart alecky and be like, oh, r is equal to 30. And you're technically right. That is the path. That is like the actual Ferris wheel. R equals 30. It goes around in one circle, and the cars are always going to be 30 away from the center. That's one way of thinking about it. The problem is they wanted the different possible positions of a passenger car at different times.
Oh, so it could be
Oh.
like 30, 35 miles per hour.
Right, it's trying to have us think about the different points that could come out. So we could have 30 at all these different angles, which r equals 30 would say, hey, whatever angle, I'm at 30, yay, yay, yay. But it also wants us to consider the time. And so, it's asking us to think of timing. Guys, does polar tell us about time? Nope, it tells us about r and theta. So technically, is this a polar equation for the positions? Yes, kind of. But the dilemma is we need to think about seconds. Passengers enter a car, interpret their coordinates after 15 seconds of rotation. How are we going to bring in time all of a sudden? We could think about parametric. That's one way of thinking about it, because parametric has time. And so we could actually be super snazzy and say, wait a minute, parametric, maybe you don't, but I can help you remember. Parametric said that we can do ellipses if we have a cosine theta and if we have a sine theta. But what we need is the minor and major axis. But the nice thing is, since this is a circle, aren't they just going to be the same? So that's pretty snazzy. We could make our center be at 0, 0, because they didn't tell us how high the Ferris wheel is off the ground. If they did, we could actually put an HK, but whatever. We'll just make this point 0, 0. That's fine. So then we can plug in different radians. We can plug in different angles to solve. But here's the dealio. That's going to help us with parametric, but that's actually still not dependent on time. Isn't that dependent on theta? Struggle. How do I get time? Hold on, pause. Can we just use logic and not even think about equations? Logic says 45 seconds. Think ACT, SAT. Logic says 45 seconds to get all the way around. Well, what's going to happen in 15 seconds? Yeah, if it takes 45 seconds, right, to be one cycle, then I could say 15 seconds would be how much of a cycle? 1/3. That would work. There are a few different ways of doing dimensional analysis to get there, but long story short, it's going to only be 1/3 of a cycle. Well, wait a minute, 1/3 of a cycle, where's it going to be? Find and interpret the coordinates. 1/3 of the way. What's 2 pi? Yeah, cut into thirds. Isn't that 2 pi over 3?
Yes.
So if I start from negative pi over 2, what angle am I going to be at if I go 2 pi over 3 from here? 2 pi over 3. Isn't that pi over 2 and a little bit more?
Yes.
Where am I at? I think I'm at 5 pi over 6. That's one way of thinking about it. You could technically actually do a negative way. Couldn't you do negative pi over 2 minus 2 pi over 3 and be snazzy like that? That'd be minus 3 pi over 6 minus 4 pi over 6, which would be the same thing as minus 7 pi over 6. Guess what positive 5 pi over 6 is the same thing as? Yep. So I could say that my point is r theta. It's gone 1/3 of a rotation, so now it's at negative 7 pi over 6. Why could that be helpful? Let's say said car breaks down or someone has an emergency. They have to emergency stop. Maybe they have like a timer as to how long the ride's been going. They could find the exact position of the person that they're trying to find. But now we know there are tons of cameras on all the rides, and so if someone gets stuck, they can usually tell exactly where it's stuck. Probably sensors on the track as well, I would guess. And I'm thinking of rides that are much more complicated than a Ferris wheel, as far as like, look, they're right there. Anyway, there you go. Then part C says, convert the point in part B to rectangular coordinates. What if to get to the poor little person, you wouldn't just rotate and then go out along? What if they need to actually go over a certain amount and set up a ladder to go straight up a certain amount? How would they get there? Well, how do we take r's and thetas and get to x's and y's? The 4 equations you were supposed to, you were supposed to highlight. So x equals r cosine theta. And y equals, what's the formula for y? Good. Couldn't you guys plug and chug this to your calculator because you're allowed to use your calculator tomorrow? Perfect. Booyah. Let's go. Pause. Oh, no. Calculator tomorrow. Let's do some quick heads up for the quiz before I just let you guys work on the review. And I'll answer questions one by one if we have them. Calculator. What if you were to do something like this and you were to plug in, if I can actually get there. There we go. The cosine one. Now, first of all, what mode would you need to be in? Radian. Why? Well, I was just thinking for this specific problem. What's the angle? It's in radian, yeah. So first of all, we'd have to go ahead, or we should go ahead and be ready tomorrow to maybe have to switch back and forth between radians and degrees based on whether they're giving us stuff with pi or stuff with a degree mark, right? Looking at our answers, if the answers have degree marks, be in degree mode. So that's one thing you might have to do. Then we can go ahead and plug and chug. Let's say we did the 30 cosine one of negative 7 pi over 6. I don't want the second, I need the 7. Kiddos, it's going to be a decimal, right? So here's the struggle. What if you get a nice decimal, and let's say you're exactly right, you're in radian mode, you know this is right, and yet there is no answer choice that shows negative 25.98076 or anything that's even rounded to be that. Let's say the answer instead shows negative 90 rad 3 over 2. Would you have been able to make it match? You can go through the multiple choice answers and plug those all in and stick it in the calculator, see which one fits. And so if we go ahead and plug that in, now you might have had to try 3 or 4 other ones first. But should you eventually have been able to do negative 90 times the square root of 3 divided by 2. Now how did I get that? Uh-oh, what went wrong?
Parentheses.
Oh, I wrote the wrong answer. No, that's not what it was. Sorry. I don't know why I did negative 90. It was 30. Yeah, 30 rad 3 over 2. I think it's technically a negative still. Sorry, I multiplied the 30 times 3 and the rad times 3. Now it'll be a lot happier. Negative 30 times the square root of. Well, we saw that the 91 would have been an incorrect answer. Go team. There we go. How did I get there? Yeah, what's cosine of a 30-degree angle in the second quadrant? It's negative root 3 over 2 times 30. There we go. So some of you might want to review that unit circle, and some of you might be like, I can make it match with my calculator. Okay. Okay, you do you. Just be ready. Be ready. But guys, we won't only have to switch between... Eyes up here real quick to help you for the quiz tomorrow. We won't only have to switch between degrees and radians. Might you also have to switch between parametric and polar? And if you're doing some sort of graph on your calculator in parametric mode, did we notice that sometimes you might have to tweak the window a little bit? Change the x's, change the y's, change the theta, I know it was time and theta, t and theta together. The t min, t max, t step. Or the theta min, theta max, theta step. Tomorrow on the quiz, your calculator might start freaking out. Or it might not be showing you anything like you think it should. If that ever happens, I want you guys to hit the zoom. And I want you to hit zoom standard. What will happen is everything gets reset in your zooms. Now we've seen that there are other funky things that can happen, meaning maybe you have some of these plots turned on and they're not supposed to be. Maybe you have to go up and deselect them. That's something funny that could happen. Maybe you're in like a degree mode when maybe you should be in a radian mode instead. Oh, I am in radian mode. Never mind. Or maybe you're in radians and maybe degrees would look better. But whenever you're graphing and something looks funny, go to zoom standard, reset it. Oh my goodness, everything's getting messed up. Go to zoom standard and reset it, and then it should help you out a little bit. Now, if you're doing some sort of real life problem having to do with time passing and you don't see degrees, my advice would be radians, because radians are much smaller numbers. There aren't many things that it needs 360 seconds or minutes or hours to complete. Chris, what's up, bud? Yes, you may. You don't normally need 360 things to repeat, or tick marks of time. Normally, instead, you need, if I can go back here, smaller numbers, and radians helps. Okay? So anyway, with your polar, with your parametric, be ready to switch back and forth between modes. With your degrees, with your radians, be ready to switch them back and forth between modes. In your notes, be ready to do some things by hand like the following. Maybe you want to take a note of this. Be ready to do some conversions by hand, points and or equations. Be ready to do some conversions by hand. Be ready to plot some points by hand. You guys take a note of this, or you're just going to remember? Okay, so remember how to plot some points by hand. Remember how to do some conversions by hand. Parametric, what's something good to be able to do? Conversions also. This was the funny one, where you start with a function or a rectangular and you have to plug in the t's, but there were 2 steps. Make x alone or isolate x and then get rid of x's identity in that equation. Get t's in there. But the more important one was the eliminating the parameter. Remember, get t by himself, take him out. Get t by himself, take him out, substitute. But guys, do you see what I just passed that got a little tricky? What was this page having us do? That was the old way. Ooh, what was so much easier? Using the formula and then plugging into the formula and being done. This is where conic sections came up. That's going to be a very good thing to look at for tomorrow as well. Eliminating the parameter, taking out t. You have to know what the directions are asking. They're asking for you to convert from parametric to function. Otherwise, know how to graph a parametric equation by hand, and that's it. Know how to graph parametric equations by hand with a table. Know how to graph polar points by hand. Know how to eliminate t in the parametric equations to convert back and forth from parametric to rectangular or vice versa. In polar, know how to convert from rectangular to polar or vice versa. In polar, you have those nice 4 equations that you can use. In parametric, you just have to remember the right order. Solve for t, plug in for t, or solve for x, plug in for x. So to that end, let's get the review. Let's get back to you guys in about 15 minutes. I have the review up here, but you guys are supposed to get out your own books, so that way you wouldn't have to depend up here. I'm pulling up the review, that way anyone who started it, I can answer any questions they have on it once I get it up. Remember, the review's at the end. Did anybody start the review and they want to ask any questions? Yeah. I'm coming to you, Jackie. Hold on. Hey, kiddos. I'm going to pause the video if we don't have any, all class questions. That's totally fine. I want you guys to work, but can we please just hear my heart that it really hurt when I graded your Chapter 10A tests and that we had, done those formulas in class and I talked about the yellow boxes, 6 days in a row, and that we've been going over the eccentricities and you guys have been popping those formulas back, and then to realize you didn't even study the formulas, the majority of you. Can we be focused? And can we study for this quiz tomorrow? And one of the best ways to study is to practice. Okay? So let's stop talking about things going on after school or things going on during lunch. Let's stop talking about volleyball games last night. Let's just focus on what we need to do right now and helping each other prepare. Okay? Look at the people around you. How you act affects their grade tomorrow also. Care about your grade, care about theirs. Ready, set, go. I have a question from Jackie, and then I'm coming back to Josh. I'm going to go ahead and pause my recording because now I'm getting particular.